Hello everyone. Welcome to the solution of LeetCode problem 40 named combination sum 2. In this problem, we are given a collection of candidate numbers and the target. We have to find all unique combination in the candidate number where the candidate number sum to target. And each number in candidate may use only once in the combination. And we have to ensure that the solution set must not contain the duplicate combinations. Let's analyze the first example. In the first example, the candidates value are 10, 1, 2, 7, 6, 1, and 5. And the target is 8. There are 4 possible combinations that make sum up to 8, which is 1, 1, 6, 1, 2, 5, 1, 7, and 2, 6. Because by adding 1, 1, and 6, the sum is 8. By adding 1, 2, and 5, the sum is 8, and so on. In the second example, the candidate value are 1, 5, 2, 1, 2, and the target is 5. Here, there are 2 possible solutions, which is 1, 2, 2, and 5. Because by adding 1, 2, and 2, the result is 5. And by including only element 5 one times, the target value also become 5. I hope you understood the problem. Now let's analyze the constraint. Here, the array length can be in between 1 to 100, and each of the array element can be in between 1 to 50, and our target value can be in between 1 to 30. I hope you understood the problem. Now let's move on to the solution by using the second example. Because second example is relatively smaller than the first one, that's why I am using it for the simplicity of the explanation. Now, in this problem, if we analyze the problem deeply, we can find that we have 2 choices for each element. Either I can take each element into the combination set, or I can simply ignore it. When we have this kind of choices, we can simply solve this problem by using the decision tree, and the algorithm is backtracking. In the backtracking approach, at first we have to see what is our input. Here the input is 1, 2, 2, 2, 5, which is the given array, and the target value is 5. So we have to find the combination by using this 5 element. Anyways, in the decision tree, this is our starting point. From this point, for the element 1, we have 2 choices. Either I can consider element 1 in our solution set, or I can simply ignore it. If we include 1 in our solution set will contain the value 1. Otherwise, our solution will remain empty. Now, from this one, we have 2 choices. Our current element is 2. Either I can include 2 or I can completely ignore it. If I include 2 here, our solution will contain 1 and 2. If I completely ignore the 2 here, our solution set will remain constant, which is 1. Now, in this problem, in our solution set, there should not be any duplicate. But what is the mechanism of eliminating the duplicacy? The mechanism is, suppose in this example, there are 3 2's here. Now, the algorithm is, if we take 1, 2 in this path, we will not take any other 2 here in this path, because by doing so, we can remove the duplicacy. Suppose in the first tree, it will contain all the 2's, and this right subtree will not contain any other 2's. So we can clearly noticing that by applying this algorithm, we can separate the 2's into the different subtree. So now here in this path, we are including another 2, which is this. So currently our solution set is 1 and 2. And if we add one more 2, our solution set will become 1, 2, and 2. But wait, the summation of 1, 2, and 2 is equal to the target. So we have found one solution here. Now, in this path, we have taken 2 2's. So we should not take any other 2 in this path, because by applying this logic, we can ensure that this path will never contain 2 2's. Or by applying this logic, we can ensure that both of the path will contain unique subsets or unique result, or both of the path will not contain any duplicate result. Now, as we ignoring 2 here, so we have to ignore all the 2's, Now our current element is 5 for this node. If we consider 5 here, our current vector will look like 1, 2, and 5. But wait, the summation of 1, 2, and 5 is 8, which is greater than our target value. So we cannot explore this path. So it is not possible for us to include 5 in this subtree. So there may be an option that we can include 5 into the other subtree. So from this one, we have two choices. Either I can include 5 here or I can ignore the 5. If I include 5 here, our current vector will become 1 and 5. If I ignore the 5, then our current vector will remain same, which is 1. Now we cannot further explore any other tree from this node because the summation of 1 and 5 is 6, which is greater than 5. So we have to stop here. Now for this empty cell, we have only the 5 remaining because we applied all the element 1 and 2 in this subtree, but we did not able to take 5 in this subtree. So we can take 5 in this subtree. Now from this empty cell, we can take 5 as consideration. If we take 5, our current vector will contain value only the 5. If we ignore 5 here, our current vector will remain empty. Now, we have already reached one of the answers because this 5 is exactly equal to the target. So in this algorithm, the results are 1, 2 and 2 and 5. These are the two combinations which sum up to 5. Anyways, I hope you understood the working procedure of the backtracking algorithm. Now let's move on to the code. In this code, at first we are given a function combination sum2. The parameter of this function is candidate and target. At first we have to apply the sort function here because by applying the sort function, it will be relatively easier for our decision tree to take the decisions. Anyways, after that, we have to declare a temporary vector and a permanent vector to store the result. After that, we have to apply a backtracking function. The first parameter of this backtracking function is the candidate array. The second parameter of this backtracking function is the target given. The third parameter of this backtracking function is the sum. At first, our sum is 0. The fourth parameter of this function is the starting position of our algorithm, which is 0. And the fifth parameter is our temporary vector. And the sixth parameter is our resultant vector. Now, in each of the backtracking call, at first we have to check whether our sum is target or not. If sum is equal to target, then we have to insert our current vector to the resultant vector. And if our current sum is greater than our target, then we have to simply return it. It doesn't make any sense to explore the tree further. And after checking each of the conditions, we have to iterate from our starting position to the end of the vector. And in this case, if our current element is equal to the previous element, then we simply continue. By doing so, we have to remove the duplicacy. And after checking this condition, for each element, we have two choices. Either I can take it or I can ignore it. If I take it, then we have to insert our current element into the temporary vector. And we have to recursively call our backtracking function from the next element. Because in this problem, we can take one element exactly one times. And our current sum will become sum plus candidate I. Because the value of candidate I will be added up to sum. Now, we have another choice. We can completely ignore this current element. To do so, we have to simply remove the last element from our current vector by applying the popback function. And finally, we have to return our result array. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.